Good morning, my students. I hope everybody is doing well. How are you coping with the exercises and the notes? Please, though you are not coming here, but do your utmost possibility to do your exercises and copy your notes. That's what we want from you people. Please, do it. For me, do it for me, please. Okay, today we have come back to continue our lessons. The subject that we are going to do is science. And our topic is what? Motion. Our topic is motion. But before that, on Tuesday we learned mass and weight. That the difference between mass and weight. And we said so many things about mass and weight. So before we come to our topic, I want to brief you on what we learned on Tuesday. We said that mass is the amount of matter in an object. Mass is the amount of matter in an object. And we said the unit of mass are grams and kilograms. Then we say that we can write the grams G in short. The kilograms too, we can write it kg in short. Instrument for measuring mass is scale. Instrument for measuring mass is the scale. So this is what we learned on mass. And when we come to weight is the amount of force that pulls objects toward the earth. Weight is the amount of force that pulls objects towards the earth. Then we said that the unit of weight is Newton. And we said it's named after an Englishman called Sir Isaac Newton. Sir Isaac Newton. The instrument for measuring weight is force meter. So when they ask you the difference between mass and weight, you can say that mass is the amount of matter in an object, but weight is the amount of force that pulls objects towards the earth. You can also say that the unit of mass is kilogram, but the unit of weight is Newton. You can also say that the instrument for measuring mass is scale, but the instrument for measuring weight is force meter. Now, let's come back to our topic today. We talk about Sir Isaac Newton. And you know, this man spent many years to know the shape and size of the planets. The shapes and then the sizes of what? The planets. He also worked out the rules of gravity. He also worked out the rules of gravity and everything that moves in this universe and how everything in this universe moves. These movements or these things are the three laws of what? Motion. The three laws of what? Motion. So we have motion means what? Movement. Motion means movement. Then we said that we have three laws of what? Motion. We have first law of motion, we have second law of motion, and then we have third law of motion. I said motion means movement. We have the 3 laws of motion. First law of motion, second law of motion, and then the third law of motion. Now, the first law of motion. Objects continue doing what they are doing unless other forces speed them up or slow them down. Objects continue doing what they are doing unless other forces speed them up or slow them down. Let's say if you are a human being, you are doing your things. Somebody, or maybe you are trotting, you are just jogging, somebody can come and then maybe hold your hand and then run fast with you, or somebody can come and then push you for you to what? Move faster. Maybe another the same person can also hold you, so that the speed that in which you are moving will be slowed down. The speed that you are moving will slow down. So any object, when an object is doing what it is doing, another object can make it speed up or slow down. Can make it what? Either to speed up or slow down. That's the first law of motion. The first law of motion. Then we go to the second law of motion. The second law of motion says heavier objects need more force to move them. Heavier objects need more force to move them. There are so many things that we human beings, we can use our hands to even carry them or move them. But there are certain things that we cannot move them because they are heavy. That's why bulldozers, caterpillars have been made to move those objects. So if an object is heavy, you need more force to move that object. That's the Newton's second law of motion. Like you have a stone, a smaller stone, you can use even your hand to move it. But if you have a big stone, you need either caterpillar or bulldozer to move it. We can use our hand to carry buckets because it is not what? Heavy. But if a car is there, it is difficult to move that car unless you use a certain machine or use another car. Or even if you can move it, you need many people to push or pull that car. So this is the second law of motion. Heavier objects need more force to move them. Heavier objects need more force to move them. Now we go to third law of motion. Third law of motion. Whenever an object pushes another object, whenever an object pushes another object, it gets pushed back in an opposite direction equally hard. Let's take it for instance, you are running. Then another person too is running. Then you come and then maybe you collide. The two of you come and then collide each other. What will happen? Everybody moves back in an opposite direction. They say the same thing. Let's look at car. If maybe a car is coming and then another car too is coming from the opposite direction and then they collide, what will happen? The two cars move apart equally towards opposite direction. The same thing if you are having maybe a ball on the ground, then you throw another ball to hit it. You see that that ball that is on the ground, that is was not moving. If you throw the one to hit it, that one, the one that is on the ground will start moving, but the one that you threw to will start moving opposite direction. So that's how Newton come out with these 3 laws of what? Motion. First law of motion, second law of motion, and then third law of motion. And when you look at all the way things used to move in this world, either that thing will move using the first law of motion, or the second law of motion, or the third law of motion. Children, this is what we will end. We will come. This is how we will end this topic today. I pray that everybody will write your notes and then do your exercises.